I'm Dr. Jacob A. Shipon, and I want to talk to you today about nanoparticles. One, what is a nanoparticle? A nanoparticle is the size of a nanometer. A nanometer is approximately 60,000 times smaller than a human hair. That's 1 nanometer. We will be in the future working with sizes that range from 1 nanometer to 200, 300, 400 nanometers. Very important, very significant. How can nanoparticles be used? First of all, a nanoparticle is composed of a central core, a coating, a organic link to an active molecule. We will discuss all of those components at another time in detail. However, it is the active molecule that is in the form of a gene or a medication or a series of genes that would treat the following: 1, cancer; 2, create an embryonic stem cell from a mesenchymal stem cell; and 3, treat genetic defects. Very big. How do nanoparticles enter cells? They are so small that they can literally penetrate a cell membrane. Not only the membrane of the cell, but can penetrate the nucleus of the cell and enter and affect the DNA. This is a very significant concept. How are nanoparticles directed to cells? They are directed to cells by magnetism. The central core of a nanoparticle is composed primarily of iron. We will discuss the different components of the nanoparticle in detail at another time. The nanoparticle has an attachment onto an organic linker, all in nanometers, that will hold an active molecule. This active molecule is directed towards cells that are to be changed, are to be treated, and are to be genetically altered by the nanoparticle. An example of this would be placing mesenchymal stem cells into a petri dish. And beneath the petri dish, there would be a very strong magnet that will attract the nanoparticles that will drive them into the mesenchymal stem cells. This will then be in an ideal position to release the active molecules that are attached to the nanoparticles to do its wondrous thing by here turning the mesenchymal stem cell into an embryonic stem cell through the addition of certain genes. Very, very major type of a accomplishment today. It will alter the future for everyone. The medications will be delivered through catheters that will be directed to the source of the problems and magnets that will drive the treatment active molecule into the cells. Because there are ways of fluorescing the cancerous tissue, and there are ways of fluorescing the treatment molecules to enter the cancerous cells, therefore being more effective. Also, remember that the genetic defects can be altered by placing magnets that will drive the normal genes into abnormal genes that are located in the body. Once the active molecule enters the area that it is supposed to enter, how is it released? These nanoparticles can be prompted to release the genes and treatment molecules by processes such as ions, pH changes, and redox reactions. Look these concepts up. We will discuss it at a later time. The future of longevity will be significantly altered by the introduction of nanoparticles and their treatments in the future. We are perhaps years and months away from having access to these processes. Very exciting time.